Hello everyone, welcome back. So in this video we are going to understand the Leetcode problem number 3640. It's a Trionic Array 2 and we have already gone through the part 1 array 1, right? Trionic Array 1, and this is the advanced problem, that is hard section. Sorry, that is a hard section, and the problem says that a Trionic subarray has 3 places in order, right? What are those orders? So it is saying a Trionic subarray is a continuous subarray from nums L to R, where this is the condition we have given, for which there exists indices like this. Okay, it means we have 3 things we have given, right? Strictly increasing, strictly decreasing, and strictly increasing. So all these 3 parts must exist, right? And which each length should be greater than or equal to 1. I hope you are understanding, right? So what is our task? Our task is to find the maximum possible sum of such a Trionic subarray, and as you can see, maximum sum of any Trionic subarray in the nums. So we have to return that. So what does a Trionic pattern look like? Let's suppose we take a nums array, and the nums array, we'll take 1, 3, 5, 4, 2, 6 and 8. If we'll take an array something like this is an array. Okay, so if we will split the array where it should be strictly increasing, strictly decreasing and strictly increasing, 3 parts we need, right? So can I say that 1, 3 and 5, let me show you. Yeah, the very first part is 1, 3 and 5. Okay, another part we can say that is 5, 4 and 2. I am talking about these 3. Okay, then we have 2, 6, 8. Okay, let me go back to some another different color. So another is 2, 4, 6. So this is, we can say that is part 1 P1, this is P2 and this is P3. So this 1, 3 and 5 that I represent P1 is strictly increasing, 1, 3 and 5 as you can say. Then we have P2, 5, 4 and 2 is strictly decreasing, and then we have 2, 6, 8 which is increasing. Strictly increasing means this is increasing, this is decreasing sorry guys, and this is increasing. I'm really sorry for my voice because I have a little cold. So this is valid because the trend is it should be up, down, up, correct? And that is why it's a valid Trionic pattern. I hope you're understanding. So if we will talk about what is the core intuition that we can solve this problem, very first is that the middle part, right, that the middle decreasing part is fixed, correct? But we can choose the best prefix from the first increasing part, and we can choose the best suffix from the second increasing part, correct? So we can maximize, right, what is the best left increase and what is the best right increase and the entire decreasing, correct? And then we can maximize it if we can find the best from here and the best from here, because this middle part is fixed. Okay, this middle or 542 is a fixed thing, correct? Then we can say we have to choose the best prefix from here to make the best left increase, and we have to choose the best suffix from the second increasing part. This will become our best right increase, and this part is fixed, so the entire increasing entire decreasing middle part is fixed, and in this way we can maximize, right? Let's go back to the code that I have solved. Okay, so we'll understand how the code works, right? And we'll understand the very first step is to detect a valid Trionic shape, right? So we know that if it is increasing, then decreasing, and then increasing, then then we can say it's a valid Trionic shape, right? So let's start with the very first thing is that count 1, 2, and 3. We know that we have the nums we have, s we have, and res we have, right? These three things we have given. Okay, let me show you. So this is the thing we have given, guys. As example we can take, and we need to find the first part, second part, and third part. Once these are done, we have to find the sum, correct? So let's suppose if very first part is this part, okay, it means you have to maximize the sum Trionic, where we need the integers, right? Integer array, and we'll check from I to n, means all the indices will go through, and then because I start with the 0, and until I is less than n, we'll search the Trionic nums, then we'll provide the index that start from and res, right? The result that we will store here, okay, and finally we'll return the res. Okay, so this Trionic function we will call, right? And we'll call this function, we'll start with the these things, right? So we can say that start with the index s plus 1, and it will go with the I. So for all the things we'll keep checking that it is increasing, the current element should be greater than the previous element, right? So they're strictly increasing. In that case, if count is equal to 0, return I. Like that we will do. Similarly, for very first we will find the ni, right? And so I'll show you what is the ni. Ni is the index we are finding here, right? And there will be ne. Similarly we'll find, so all the count, this is for the starting index that we will say, in for the increasing index we can say that, and this is for the ending index, okay, we can say that. So we'll find increasing, then we'll find the decreasing one, and then again we'll find the ending one. Okay, like that we will find, guys. Once these three are able to find, we will use the int e I minus 1, then we'll say dec, we'll add these values of here, right? And we'll make a for loop, and we'll keep adding all the value, right? So we want to check the values there, so we'll keep adding all those values here. So index will start for the ni, it will goes to the ne, and we'll do plus plus, and we'll keep adding all the values. Now we have increasing 1, increasing 2. We will take two things. We'll check the, we'll do the shifting, and then we'll find the array. I will explain you later, but just go through. And the increasing max will be there, so we'll find the max from here. Merely with the max part means the prefix and the suffix we'll find from the increasing one, and we'll add the fixed one, right? If it is maximum will return the maximum. Okay, so let's come back to here. The very first, we know that these three part is easy to understand, correct? Then we'll go to here. I know you will stuck here. So basically what we are doing here is we want to find the sum, the decreasing middle, right? So this is the decreasing middle. We will find the sum, the decreasing middle, you can say that. And that is why we start with the 0 and we'll go with the ni and till the last ne, and we will find the decreasing one. Okay, so this part must be included fully, so you have to take this first. Okay guys, then the best prefix sum on the left and the best prefix on the right side we have to find, right? So for that we need to increasing 1, increasing 2 we have to take, right? So increasing max we will find, as you can see here, right? So why? Because maybe using only one part of the increasing, right? What I said, we will be finding the best sum prefix, best prefix sum we can say on the left part, and because this is the increasing max, we can say that. Why? Because we may be using only one part of the first increasing segment, which gives more sum. Okay, similarly we'll find the increasing 2 here, and the same idea on the right side we will do that. Okay, I hope you're understanding. Once these are able to find, so we will update our answer. So answer will keep updating here. So the res, that result we have created in the main function, so it will keep updating all these indices. Okay, at each indices you will find the max sum, you can say that. Okay, that will be our result. So at res 0 we will have the result. Okay, so this value will get updated at here res 0, we can say that. Okay, means we have to skip the head, right? So we have to skip the head here. Why? Because any valid next trionic must start after the middle decreasing part, guys. Okay, and that's all I have in this video, guys. And you will finally will return the value that where you have saved the max sum of the increasing, decreasing, and increasing 1, increasing 2 on, and the fixed part decreasing 1. So we know that we have to fix the valley, you can say the downhill, and then we have to extend optimally the both side, increasing 1 and increasing 2. So that's all I have in this video, guys. I will say that do not try brute force approach where you will try all the substring, means we want to check every subarray and you want to verify it's trionic or not. So do not try, because that is a simple logic and it will give you the time limit exception O of NQ, right? So don't try that one. If you're trying to do with the DP with the trend state, so the idea is to that if you will want to find the DP with the states up, down, and up again, so that is an elegant concept you can say that, but it's hard to implement, guys. So don't try with that. It will take extra memory also. That is also not a good idea. If you want to try the monotonic segment and the prefix sum, so pre-compute increasing and decreasing segment and try the combinations. But the problem is that it's faster, but it's very complex edge cases are there. So maybe the edge cases will fail there, right? If you will try the best approach, right? So the current approach is the best approach, guys. It is taking O of n as a time complexity, only one pass we need, no extra memory we need, and the problem is that it's little hard to understand initially. So this is our intended for the competitive solution, guys. Make sure that you understood this. If you're not understood, you can ping me the comment box and we can go from there. Okay, so that's all I have in this video, guys. In case you have any doubt, please ping me the comment box. And to summarize this, you know that we have the given function we have given, we have to implement this, and then we have to check the trionic and you will find the maximum. So maximum once you will find, you will store at the rest and you will return the rest result at 0. Okay, basically if you talk about the intuition, that we start from the index I, guys, right? And we want to try the building up, down and up, right? So if it's valid, right, we will log the middle and will stitch left and right greedily, so we can find the max answer, max sum, we can say that, for the increasing one and increasing two, because this part is locked part and it will be fixed, but only these two part we will try to find the max, right? And then we'll keep updating our answer, right? We have to track our answer, and once we track the answer, we will jump the forward and we'll repeat this again, and once these are updated, once these are done, you will return the result where we have stored the sum, guys. Okay, so that's all in the video, guys. Thank you, bye bye. I'll see you in the next one. Keep learning, and please support ExpertFunda by liking the video and subscribing the channel, and please share this video with your friends and colleagues where you are learning with them. Okay, try to collaborate with friends so you will understand better. Thank you, bye bye.